Hello everyone. Have you ever wondered how AI actually learns? When you unlock your phone with your face, when YouTube recommends a perfect video, when AI tools like ChatGPT answer complex questions in seconds, what's happening behind the scenes? The secret is something called a neural network. And today, I'm going to explain exactly how neural networks actually work in the simplest way possible. No heavy math, no complicated formulas, just pure logic. By the end of this video, neural networks will never feel mysterious again. You will understand the core engine behind modern AI. Let's break it down. Why do we need neural networks? Okay, we have talked about AI, machine learning, generative AI, and LLMs in our previous video. But here is the real question. How does AI actually learn? Traditional programming is simple. If this, then do that. If marks greater than 35, the result is pass. If temperature is greater than 100, the result is fever. Nice, clean, predictable. But real life, not that simple. How do you write rules for face recognition, voice assistance, stock prediction, language translations? You can't write millions of if-else statements. So instead of giving rules, we give data. And the system learns patterns from the data. That system is called a neural network. But wait, why neural? Is it really related to our brain? Yes, and that's where things get interesting. Inspired by the human brain. The word neural comes from neurons. Your brain has billions of neurons. Each neuron receives signals, processes them, sends signals forward. One neuron alone? Not that powerful. Billions connected together? That's intelligence. Neural networks copy this idea. They have input layer, hidden layers, and output layer. Let's say we show an image of a cat. The input layer receives raw pixel data. Hidden layers start detecting patterns, edges, shapes, ears, whiskers, and the output layer says it's a cat. Simple. Neural networks don't think like humans. Instead, they predict patterns. That's the secret. How does it actually work? Now let's break it down. Four simple steps. Step 1. Inputs. This is your data. Example, house price prediction. Area, location, bedrooms. Weights. Not all inputs are equal. Location, very important. Wall color, not so much. Weights decide importance. Step 3. Activation. All weighted inputs are combined. The network calculates a score. Should it fire or not? Step 4. The output. The final prediction. But here's the powerful part. In the beginning, the network is terrible. It guesses randomly. Then it checks the real answer. If it's wrong, it adjusts the weights. Again, thousands of times. Each time reducing the error. Slowly, it becomes accurate. That adjustment process is learning. That's how AI trains itself. Neural network versus deep learning. Now you have probably heard this term deep learning. Here's the difference. If a neural network has just a few hidden layers, it is a simple neural network. If it has many hidden layers, it becomes a deep neural network. And that is deep learning. Deep learning powers tools like ChatGPT, it powers voice assistants, image generators, self-driving cars. Modern AI runs on deep neural networks. So when you chat with AI today, you're talking to a massive network with millions, sometimes billions of parameters. That is powerful. Where are neural networks used? Neural networks are everywhere. Face unlock on your phone, fraud detections in banks, medical diagnosis systems, stock market predictions, recommendation systems suggesting your next video. Behind all of it is pattern recognition. Let's summarize. A neural network is a brain-inspired system that learns patterns from data by adjusting internal weights to make predictions. This is the engine behind modern AI. Alright, now we are entering the most important part of neural networks. This is where the learning actually happens. Remember, we spoke about adjusting the weights again and again and again? That's called backpropagation. So imagine the network makes a prediction and it gets it wrong. What does it do? Does it panic? Nope. It calculates the error. It literally measures how far was I from the correct answer. And here's the crazy part. That error travels backward through the network. From the output layer, back to the hidden layers, all the way to the input connections. And as it travels back, it adjusts the weights. Tiny adjustments, again and again and again. This process repeats thousands, sometimes millions of times, each time reducing the error just a little bit more. That's backpropagation. It is basically the network saying, oops, that was wrong, let me fix that. And that right there is how neural networks learn from mistakes. Alright, if you have made it this far, you're officially ahead of 90% of the internet. So far, we have covered what is AI, machine learning, generative AI, LLMs, neural networks, and even backpropagation. And trust me, this is just the beginning. In the next videos, we are going deeper. We are going to break down tokens, embeddings, vectors, and how LLMs actually understand text. Now I want to hear from you. What topic should I cover next? What confused you the most? Drop in the comments. And if this video helped you even a little bit, hit the like button, share it with someone learning AI, subscribe to the channel, and press the bell icon so you don't miss what's coming next. We are building real understanding here, not just buzzwords. I'll see you in the next one.